Welcome to Study Loop.
Hi, in the given problem, here this is the globe of the Earth in which the direction of Earth's magnetic field is this, due north, and a bullet is moving due east like this. So, if we consider the bullet to be looking like this, its height, this is the height of the bullet. This height of the bullet will be intercepting the magnetic field lines perpendicularly. The Earth's magnetic field has been given as B is equal to 8 multiplied by 10 raised to the power minus 5 Tesla. This height means diameter of the bullet has been given as 0.4 centimeter, or we can say this is 0.4 multiplied by 10 raised to the power minus 2 meter. It is moving due east with a speed of 300 meter per second. So, first of all, we have to check which of the end of this bullet will be at a higher potential. So, on applying Fleming's right-hand rule, in which we stretch the thumb, the index finger, the middle finger of our right hand perpendicular to each other. The thumb gives the motion of this conductor. The index finger gives the direction of magnetic field. Then the middle finger gives the direction of current induced. So the current will be moving from bottom to top. So definitely the top end will be at higher potential, as in the motional EMF, the current moves from low potential to higher potential. So the top end of the bullet, the top surface of the bullet will be at higher potential. Now, we have to find the value of this EMF induced, and that is simply given by the product of magnetic field with the speed and the length. Here, this thickness of the bullet will serve as the length. So, putting these values, 8 multiplied by 10 raised to the power minus 5 Tesla, multiplied by 300, multiplied by 0.4, multiplied by 10 raised to the power minus 2. This EMF induced here comes out to be 9.6 multiplied by 10 raised to the power minus 5 volt. So these are the two answers for the first part of the problem. Now, in the second part of the problem, they are saying what is the EMF if the bullet travels south, means if this bullet start traveling due south. In that case, the velocity vector will be anti-parallel to magnetic field vector. So we know the condition for this motional EMF is that the magnetic field, the speed means velocity, and the length of this conductor, all the three should be perpendicular to each other, exactly perpendicular, not even anti-parallel, as here in this case the velocity is anti-parallel to the magnetic field, so EMF induced will be 0. And in the third part of the problem, they are saying the EMF induced we have to find between the front and the back of the bullet for any horizontal, means we have to check whether there will be any EMF induced between front and back of the bullet. So now in this case, the velocity of the vector, velocity of this bullet will become parallel to its length. So again, there will be no EMF induced in that case also. E is again 0. So here the case was the velocity was parallel to magnetic field, that's why EMF is 0, and here the velocity was parallel to length of the conductor, that's why the EMF induced is 0. Thank you.